Good morning everybody. In this class we are going to discuss about operational amplifier. Okay. Why it is called operational amplifier? Because it is used for different type of mathematical operations such as addition, subtraction, integration, differentiation. Okay. The ideal characteristic of the operational amplifiers are the input impedance of the operational amplifier is infinite in ideal case, but practically is very high. Okay, this is the circuit symbol of the operational amplifier. There is two input. This is inverting input and another one is non-inverting input. Okay, why it is called inverting input? If we apply input signal at that input terminal, then there is a 180 degree phase difference takes place between the input and output. So if we apply the positive signal here, then we will get the negative signal, and if we apply the negative signal, then we will get the positive signal. 180 degree phase difference takes place between the input and output, so it is called the inverting input. Now another input is called the non-inverting input. If we apply input, no phase change occur here. If we apply positive signal, then we will get the positive signal. There is no any phase difference between the input applied at that input terminal and between the output. Okay. In the first character of the operational amplifier is input impedance is infinite in ideal case. Here this is the input impedance. That means the resistance between the input terminal. This is the input resistance. Okay. Practically the resistance is very high, but in ideal case it is open. No current flowing through the input terminals. Okay. So the input impedance is infinite in ideal case. Output impedance is 0 in ideal case. This is the output impedance, but practically the output impedance is very small. In ideal case output impedance is 0. Voltage gain means output voltage by input voltage, but for operational amplifier, for ideal operational amplifier, the open loop voltage gain is infinite. What do you mean by open loop? If we apply a resistance between the input and output, it is called the feedback resistance. Feedback means fraction of the output feedback to the input. So it is the closed loop. But if we do not apply the feedback resistance, then it is open loop, and in that case the voltage gain of the amplifier will be maximum value. What will be the input? Okay, actually it is differential amplifier. It amplifies the difference value of the two input signals. So whatever be the value of the difference between the input signal, here the maximum voltage, we will get the maximum value of the output voltage. Okay. Number 4, bandwidth is infinite for ideal operational amplifier. Bandwidth infinite means the operational amplifier in ideal operational amplifier, we can apply it in the infinite frequency range. There is infinite gap between the lower cut of frequency and upper cut of frequency. And third one is the perfect balance circuit. What do you mean by perfect balance circuit? Actually, operational amplifier is a differential amplifier. Differential amplifier means output voltage V0 equal to AD into, if the input signal applied at the two inputs, V1 is the input applied at the inverting terminal and V2 applied at the non-inverting terminal, then the output voltage of the operational amplifier will be V2 minus V1. This is the expression of the differential amplifier. So if the two inputs are equal, V1 equal to V2, then the output will be 0. That is why it is called the perfect balanced circuit in ideal case. Okay. But practically, the operational amplifier do not only amplify the difference mode signal but also amplify the common mode signal. So, for practical amplifier, the output voltage will be V0 equal to AD V2 minus V1 plus AC V2 plus V1 by T. Okay. There are two terms. This is comes due to the difference mode signal and this is come due to the common mode signal. So, practical operational amplifier also amplify the common mode signal and this is the gain for common mode signal. Okay. But common mode gain of the amplifier degrade the performance. For good operational amplifier, the common mode gain will be smaller. Okay, and an amplifier how much successful to reject the common mode signal and amplify the different mode signal is measured by a parameter is called common mode rejection ratio. How much successful to amplify the difference mode signal and reject the common mode signal, and it is measured by a parameter is called CMRR and the expression of it AD by AC. Okay. In decibel it also can be written as 20 log AD by AC. For better performance, AC tends to 0, and if you consider the ideal operational amplifier, then CMRR will be tends to infinity because IC is 0. Now I will discuss one very important point for operational amplifier, because without the knowledge of it we cannot analyze the operational amplifiers, and this is virtual ground concept, and this is very important concept. If we connect the non-inverting terminal to the ground, and if we consider potential here, suppose this is B point, so the potential is VB, and A point there is input resistance, and this is feedback resistance, this is input resistance, and this is input signal, and this is B point, and this is the input and this is the output. Actually this is differential amplifier, so it amplifies the difference of two input signal. Okay, so the input is Vi and Vi will be amplified by the operational amplifier. So the voltage gain AV equal to V0 by Vi. Okay, and since the voltage gain of the operational amplifier is infinite, but practically is very high, but for the calculation we always consider the voltage gain is infinite. Okay, so this tends to infinite means for Vi is equal to 0 we will get finite V0. Since it is infinite, so V0 will be finite for Vi equal to 0. Okay, Vi equal to 0 means from the circuit Vi equal to the potential at A with respect to potential at B, this is equal to 0. Okay, so Va equal to Vb, that means the potential at A and potential at B, both the points remain at the same potential, and since the B point is grounded, so A is also ground. So the point A is called the virtual ground point. Okay, thank you.